Team, what's going on? Seismic PE prep example number 14, coming right at you. Let's get into it. For the one-story building shown, the story drift ratio is most nearly what? If you're just catching on, you know that we're going to be heading into the ASCE 716. Further down the road, if you're coming back to this video like years from now, the code cycle will update and it will move to a later version. So make sure that you're checking against which version of the ASCE you're working with. It's a single story structure, 20 feet tall, 10 feet wide, 30 kip story force applied up at the roof level in green there. And then there is a resulting 2-inch displacement. If you happen to see anything in the exam about drift or displacement or story drift ratio, you know you're gonna be heading to section 12.12 of the ASCE 7. Let's head there now. And we're gonna start at the very beginning, 12.12.1. The story design drift, delta, as determined in section 12.8.6, 12.9.1, or 12.9.2 shall not exceed the allowable story drift, delta sub A, as obtained from table 12.12.1 for any story. Well, not that it asked for it here today, but allowable story drift table is just down below here. Here's this nice table. It's one that you're gonna use often in the professional field, but they didn't ask on this, so let's stay on subject. Well, let's first head back and check out these 3 sections to see which one may be applicable to us. Section 12.8.6 finds you in story drift determination, and this is within the ELF chapter, or the equivalent lateral force procedure, which I would say is where we're gonna find ourselves here today. Section 12.9.1 finds you in the linear dynamic analysis section, and 12.9.2 finds you in the linear response history analysis section. Both of those sections you're not gonna be asked questions on, I wouldn't think, for the exam. So let's stick with 12.8.6. Primarily in the professional field, you use the requirements in this section, as well as some that bleed into the next page, as well as this figure here. 12.8.2, story drift determination, is a very powerful figure that has a lot of information contained within it. Up above talks about torsional amplification. Again, that is a different subject for a different problem. We want to stick this right here, as well as the contents below it. And you'll note, as it says, note, delta sub I is story drift. Delta sub I over L sub I is story drift ratio. And then, God, I can never remember this Greek letter. I'm gonna call it lambda. Lambda sub X is the total displacement, and I is the level under consideration. Well, bing bang boom, story drift ratio, that's what we're after here today, was just a little simple equation. So story drift divided by L sub I, which is just the height of the story under consideration. And really, that's the meat and potatoes of it all. So let's go back and let's plug everything in. Story drift ratio, I'm just gonna abbreviate it to SDR, is equal to story displacement over the height of the story. Well, we said I is equal to 1. L of the story under consideration. We only have a single story building, so if I go blue, we know it's just gonna be that 20 feet. It didn't talk anything about the width of your structure. Drift only considers height of the structure. So this 10 feet down here is just an additional bit of info that they're trying to kind of spoon-feed you along and make you go in the wrong direction. So 10, we're gonna ignore. That 2 inches, so that's the story displacement at story I, which we know in this case is the top of story 1, because it's a single story building. When you talk about drift and displacement, it's always in terms of inches. You're not permitted, I mean, unless you have like the Burj Khalifa or something, you know, massively tall skyscrapers where they move several feet at the top. But otherwise, for normal everyday structures, you're only talking about permitting those types of buildings to move only a couple of inches. So keep all of your units in inches when talking about this. That's 240 inches. And then delta sub I for our single story is gonna be 2 inches. And then we'll just do, for fun, we'll do F1 for our story force equal to 30 kips. SDR is equal to 2 inches over 240 inches, which spits out 0.0083. Now, this is a ratio, so this is unitless. It's inches divided by inches gets you a unitless value. That ultimately today will get us our final answer. So if we scroll back up and we go green, I would say 0083 is closest to answer A of 008. Don't go anywhere though, because let's talk a little bit further on this and try to, include some additional context to this problem that may well be another problem that you encounter on your exam. Oftentimes, professional engineers, I feel like it's Might be split 50-50, maybe not. Go about checking their drifts either based on ratio or based on the actual numerical value in inches. I personally like inches because it's a real number to me. So I can visualize in my head, okay, my building is only permitted to move 8 inches total. Oh, and when I did my calculations, I can see that my total story displacement is 6 inches. 6 inches is less than 8 inches, so I'm okay and I can move on. Other engineers, however, love to just keep it in ratio form because you don't need to go through the extra steps of plugging in values to get a comparable answer. You can just say, well, as long as my ratio is less than the allowable ratio, then I'm all done. Now let's spice it up a bit. We saw earlier that there's a table that has allowable story drift. So the ASCE 7 only permits so much movement of a structure based on that structure type. Well, let's take the information given in this problem, let's add a little bit more context, and then let's compare it against allowable values found in the ASCE 7. I'll go green here. Our added context is that we are going to be a risk category 3 structure. We're going to assume this is seismic controlled, so EQ controlled, and we're going to say our structure is a masonry shear wall system. And all these values up here in the figure still apply. Well, first, let's head back to the ASCE 7 and check out that allowable drift table. All right, so we said we are risk category 3. You can see it's dependent upon your risk category and your structure type. So I specifically said we're gonna be masonry shear wall structure. You can also call it a masonry cantilevered shear wall structure. There is a footnote there. Let's always read our footnotes. Structures in which the basic structural system consists of masonry shear walls designed as vertical elements cantilevered from their base or foundation support that are so constructed that moment transfer between shear wall couplings is neglected. Let's assume that here today. So if we go over and we come down, that's going to land us with this equation here. So delta sub A, or our allowable story drift, is equal to this equation. Well, H sub Sx in the footnotes here is the story height below level X. We know we have level 1 that we are considering. So we need that 20-foot dimension to plug in for H sub Sx. So let's head back and do that. All that plugged in spits out 2.4 inches, which equals delta sub A. Well, we can compare against the number of inches or displacement of the structure that was given in the problem. So 2 inches is less than our allowable story drift per code, so we know that we have a code compliant structure from a drift perspective. Another way we can look at it is comparing ratios. Let's do that now. You simply divide out H sub Sx from the equation for allowable drift. That just gets you allowable drift equal to 0.01. And you can compare that to your structure drift ratio, which was 0.083. We know that the allowable ratio is greater than 0.083, so we also know our structure is compliant. So 2 different ways to look at it, but they've yielded the same solution every time, or at least they should, and it just depends up to you as the design engineer how you want to keep your calculations nice and neat and tidy. But that'll do it for today's example. I hope you liked in this little additional context we threw into it. We asked some additional questions and we went through the code a little bit more. If you're liking what we saw here today, subscribe down below. I appreciate all of you here that are already here in the auditorium and have subscribed so far. Really do appreciate it, and I'll catch you in the next one. Peace.